let me know when you're.
I'm ready.
5, 4, 3, 2.
Yep.
Hi, boys and girls. It's your local and neighborhood science instructor, Mr. Cunningham. You'll come to know that before I had this wonderful job of educating the young minds of South Haven, I was a male model. Case in point, I'll give you my patented pose that earned me lots of money all over the world. All right, enough of that. It's about you, not me. All right, so wave types. What are the two types of waves? Last time we talked about how waves take energy from one place to another. And waves that take energy and have to go through a substance, we call mechanical waves. Sound wave being an example, seismic waves, if you ever heard of earthquakes, those waves have to go through the Earth's interior, if you will, but those waves have to go through something, okay? Light waves or electromagnetic waves can go through empty space. But Mr. Cunningham, how do these waves move? In what manner do they move? That's a good question, good question. How they move, we categorize a wave by how they move. So wave types, there's two. One is transverse. Transverse wave. Now a transverse wave, you put that down so I'm free. Oh, much better. A transverse wave is a wave that moves, well, oh, did you see that? Oh gosh. Yeah, that was a transverse wave. Okay? You ever see the wave at like a football game when everybody stands up and sits down? That's a transverse wave. You get this action, like this. Oh, you're good. Okay, now, have you ever saw maybe like a snake slither? It's this way, right? But if you think about it, it's the same thing as this, but it's that way. That's a transverse wave. In math class, we call it a sine curve. Anybody in algebra, you know what a sine curve is? No? Algebra? No? Maybe I'm too quick. So a sine curve is an example of a transverse wave. It's mathematically how you draw a wave like this. Anybody ever saw that in math? You never saw a graph like that? You have? That's a transverse wave, okay? It's the movement of a snake if we turned it on its side, this graph on its side, yeah, like that, all right? So that's how the energy disturbs the atoms or molecules when it goes through the substance. So when sunlight comes through the room, it makes the air molecules do this. That's why we classify light waves as transverse, okay? If you were to hold the rope here and do this, you would get this effect. That's a transverse. See how this looks like that? All right? Now, here's the thing. If this gentleman backed up and held the wave or held the rope straight, it would be a straight line, right? But he's using energy to cause the disturbance. That's the wave, is the disturbance. Okay, this is the rope just held straight, no energy. We start putting energy to it, and we get the wave. Now, the energy is going from here to here, would you agree? From there to there. But what is the rope doing? Is the rope going from here to there? No, the rope's doing what? Going what? It's going up and down. So really, when you think about how the rope moves compared to, the rope is doing this. But the energy is doing this. So that's perpendicular, is that right? I think that's the math word, right? Energy's going that way. The rope is going that way. Aren't they going perpendicularly to one another? Is that the word? Say yes, in agreement. It's rhetorical, of course I'm right. Okay, yeah, so that's what we call a transverse wave. Now, could this person holding the rope do it this way? What would happen to the rope? It would go like that, wouldn't it? Into the board, out at you. Isn't that still perpendicular? Transverse. Transverse. And a light wave is a great example of a transverse wave. Great example of a transverse wave. Oh, very nice. We won't get too far into that. Parts of a transverse wave. Can you give me like minute markers, like every once in a while? Like if it was 7, just go, I'm real smart like that. Okay, so the parts of a transverse wave. The parts of the, we have a crest, which is the top of the wave, so that's the crest. And the bottom is the trough. How could I make the crest and trough bigger if I was holding that rope?
Go higher.
Like take my hand and do this? Go higher then? Is that more or less energy? What?
More.
So you're telling me that the height of that is related to the amount of energy? Write that down. So you teach yourselves. A wise man once said, I cannot teach anyone anything. I can only inspire them. That wise man was me. Circa 2003. You want to be on camera again?
No.
Then you better get quiet. All right, so the energy is going to be proportional to how tall this is, and this is going to be, look, this and this will be the same. Remember this dude named Newton? Fig is his mom. Isaac Newton. Fig is his mom. You get it? Fig Newton. No? All right, fine.
Anybody? Fig Newton?
I don't know what I'm going to do. You guys don't get into the jokes. It's ridiculous. All right, so this, remember, equal and opposite for every, all right, you didn't study, that's fine. For every action, there's an equal opposite reaction. So when we do this, and the rope goes up there, it goes down by the same amount. Okay? Now, I want to show you, there's a word that we use for that. Oh, man. I want to go to the other one first. There it is. How tall that is called the amplitude. 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 Where am I? Oh, amplitude. How tall? So the amplitude tells us the energy value, if you will. It tells us, you know, if the amplitude's big, there's more energy. Amplitude small, small energy. So think of it this way. If we're talking sound wave, crank the volume up. That's doing that to the wave. Are you following what I'm saying? Volume, more energy, the amplitude's getting bigger. Anybody have a dimmer switch in your house? You got a dimmer switch on one of the, okay, do this to the dimmer switch, or that, and it's you with me?
Yeah.
Okay, so, proportional to energy. I want to go back to, where was I at? Oh, there we go. There's a couple more words I'll use. We had crest, trough. Okay, wavelength. So I hope you drew a wave and you can kind of fill all this stuff in. Maybe I'll fill it in with you. So we said this was the amplitude, right? Hopefully that'll show up. Amplitude. Okay? That's that. And we said that was the crestal region. And that baby right there is the trough. All right? Oh, beautiful instructor. Beautiful drawing. Okay, so how long is a wave? From crest to crest is one wavelength. From trough to trough is one wavelength. You see how they did it here? Wavelength, wavelength. So if you're at the beach, okay, you're not going to see the trough. You'd have to dunk your head underwater and it wouldn't be visible, right? So you're looking at, oh, crest, I saw that one. Another crest, that was the length of the wave. So we measure wavelength like with meters, centimeters. Depending if we're at the beach, it'd be meters, okay? Oh, this is good stuff. This is good stuff. I'm gonna let you in a little secret. I haven't told my wife this, all right? So you guys are gonna learn something very, very informative and secret. Watch this. This is also a wavelength, people, from there to there. Crest to trough. Am I making sense? You get it? Okay, so that's also, so I can measure wavelength, and they're all gonna be the same number if it's on the same sequence of waves. Couple more words. Ooh, I tried. Cut the music, I can't go any further.